Okay, so this is exactly where we stopped last time, simulating our so far done buttons. Now we are going to close this one and go back. So we are going also to give functionality to the rest of the buttons. Now here we are going to go and update the ladder logic. We are going to go off monitor mode. Do you want to go offline? Just say yes. Now here you are going to allow me run through the ladder circuit as you watch. I'm just going to copy. Those who watch for Mitsubishi, I'm just going to copy and paste. Not copy and paste, but exactly what I did the other side is what I'm going to do this side to show you that with the circuit development, it's just a general thing. So here, remember, I have here manual memory, I have here auto memory. Now here I'm going to have a normally open of manual memory. Once manual memory is on, I'm going to have two buttons. One is for forward and I'm going to have a branch. One is going to be for reverse. And they are both going to power. This one is going to be a forward memory. This one is going to be a reverse memory. So I'm going to define. This one already exists. This one I'm going to auto memory. It is manual memory. So this one I'm going to say this one is FX button, that is forward button, and this one is RX button, that is a reverse button, and this one is FX memory, that is forward memory. So here, memories in our normal circuits of relay logics, you can refer to a memory as a supportive relay. So here, this one is going to be a reverse memory, that is RX memory. Okay, so all these are memories. All these buttons are memories because we don't need the physical connection to the PLC. They are just going to get commands from HMI, which is also software based. So I'm going to have this. This is global memory. So define. I'm going to have this define tag. Global memory. Define. I'm going to have this define tag. Global memory. So these startup times, we have to go slow, everything, no rushing, no jumping, anything, so that after we have got the basics, we are going to start rushing, jumping some other things in future projects. So this is when the manual is on. This forward button can work with the forward memory. Reverse button can work with the reverse memory. So also when we come to our screens here, conveyor screen, these are the buttons. So you double click, then you come here to properties. So where is it? Yeah, it is this one. So also you are going to give it event. So when you press add functionality, set bit of which tag. Here now we have not created the HMI tag for this one. Okay, let's come here to default target table for HMI, add new. Here is RX, FX memory, FX button. We have RX button. We have FX memory. We have RX memory. So here FX button is going to work with FX button, of course. Then here is RX button. That's why I like naming them the same way, so that here is RX button. You say okay. Then FX memory is going to work with the FX memory. Then RX memory is going to work with the RX memory also. It is down, which is this one. So okay. So that is it. So when you come to screens, conveyor screen, so this one forward, you can give it FX button, which is here. Say okay. Then when that is setting a bit, so when you release, we are going to reset a bit. Reset bit of the same tag, FX button. So okay. Then reverse. Here we are going to have, when you press set bit of which tag? Reverse, which is here, reverse button. So okay, yeah, reverse button. Then when you release, we are going to reset a bit. Reset bit of reverse button. So okay. Okay, those are these buttons finished. So these ones we are going to put later. So I think we now have to deal with the automatic part of it. You drop the properties, so come back here to main OB circuit. So in main OB circuit, we are going to have here, once main OB circuit, we are going to have here auto. Let me check. Normally open. So here we are going to have, once the auto memory is on, we are going to have here, now here we have start and stop. We have here start. Come. What's it? We have here normally open, start. We have here normally closed, stop. We have here a branch to select hold the thing. We have here a normally open. Then drag and drop this branch here. And here we have that coil that is going to help us in retaining the stop and the start functionality. So here is start. Here is stop. Remember, all these are just commands from PLC, so no need for physical components. And here is the, can I call it start memory? So I'm going to define this one. Global memory, so I define this one. Global memory, I define this one. Global memory, I define this one. This one not defining. I'm just going to click from existing, that is start memory. It is this one is going to hold itself. So now when the start memory is on, normally open, this one is start memory. If I'm taking you fast, you can just go slow as you try to analyze the circuit properly. So when the start memory is on, we are going to have here, which button do we have here? Any button to press? No. we are going to have a sensor. Behind the sensor, you are going to have, now here a sensor is a physical component that you have to input into the PLC. Then we are also going to have another sensor. Then we are going to have, this is forward. Oh, it is a coil. Delete. Here I need a coil. So here we are going to have a behind the sensor. I'm going to call it BS, that is behind the sensor. Then here I'm going to call it FS, that is front sensor. Then this one I'm going to call it FX memory. Do I have something like that? Yes. Now, forward memory. Okay, this is FX memory too. FX mem 2. No problem. So it is going to be, this one is normally closed. Now here, these sensors, it is because we are using normally closed sensors. This one, it would have been normally closed, but it's going to be open so that once a sensor signal comes, it is closes it. This one is normally, this one has to be closed so that when the sensor signal, here sometimes it is confusing. I don't know how I can clarify it. So, if not that one, this one can still be initiated by the start button. Let me see a branch here. I have here a start button. Do I have start button here? Start. I have this. Then it is going to also do what? I'm going to have another branch to self-hold. This one, FX memory. I have not defined this one. This one is just a memory. This one is a sensor. This one is just a memory, define tag. Global memory, define. This one I'm going to put here. Then this one, this here is FX memory too. Then now this one is I'm going to define tag. This one is the global input. Now it is an input device because it is a sensor. We need to connect it directly. It is starting from 0.2. Then say define tag. Then this one also define tag, a front sensor. It is a global input. So hope you see with the inputs we are using I. So on this very round, that one is for forward movement. Then here the very thing when the start memory is on, start memory is on, still we can have here. Now here we started with the behind sensor. Here we are going to start with the front sensor, which is going to be normally closed. It has to be, in a real sense, everything that is starting a circuit has to be normally open. And anything starting a circuit has to be normally closed. But here you will find that I'm using normally closed to start and normally open to stop, just because the sensors I'm using are normally closed in a factory I/O. So when they bring the signal ready, they are going to make this one open and this one closed. That's what I'm trying to mean. So this one is front sensor, FS, and this one is back sensor, BS. So you see it is the vice versa of this one. Then here, I'm just going to have a self-holding. Over here, I'm going to have reverse memory 2, which is going to be the coil. This one is going to be RX memory 2. Then here I'm going to have a self-holding branch of this one, which is already there. I have not yet defined, so let me first complete this. I'm going to define this one, which is just also global memory. Define. And now here I'm getting the already existing, which is RX memory 2. Okay, so that one is finished. So now what is remaining is the real outputs. The real outputs, we are going to have here the conveyor forward. We have here forward coil. Then the last network is going to be the reverse coil. Here we are going to have now forward, real forward movement of the output, and here we are going to have reverse, not the memory this time, they are now outputs. So here when you define tag, we are going to have global output, because these are physical components that need to be directly connected to the PLC. Here is global output. Define. Oh, here again I said the input. What's wrong? I'm going to delete this one. This one I'm going to say rename tab, rename tab. Here is it. Okay, what I'm going to do is delete that one. Now this one, if I put reverse, forward is going to bring the same thing again. You see it is already there. What I'm going to do is I'm going to come to these PLC program blocks. I have PLC tags. Double click here. Click once. Then is standard variable, double click to get PLC tags. So I'm just going to edit here forward. This one I'm going to say 2. Then this one I'm going to say output 1. Say okay. So have you seen how I can also change the tags? So when I come here to main OB, you see now forward, and here when I just click the already existing, which is the reverse. So this one is Q1, this is Q2. So the forward is going to be powered either. We have 2 powering items, one in manual and one in automatic. The one in manual, it is the one we call forward memory, FX-mem. And then the one in automatic is the one we called FX memory 2. Forward memory 2. They are all going to power. The one which is on is going to power the forward motor. Then also reverse, we have 2 of them, one manual and one automatic. Click here. The one for manual is called RX memory. RX mem. Then the one for automatic is called RX memory 2. So those are the 2 that are going to give these outputs. So I'm just going to try compile this and see if it works out. Block was successfully compiled. Then here, download to device. Remember, we are already in simulation mode. Say load. Loading is finished. Okay. So as I told you, you can either go to monitor mode or you can leave, but me, I don't need to watch this. So let me come to her. Now we have very many HMI tags to define. Let me come here and see. In HMI tags, we have here, these ones are the tags in in PLC, we need to define all these tags in HMI. It is not the only way, but it is the hard way, the default way, and the most understanding way, step by step. So we have to define all these ones also in the HMI. Since HMI we only have these ones. Let me try to okay. So what I'm going to do here is I'm just going to make this one floating and minimize it a bit. I just want to copy. Do I have the addressing? This one is for the HMI. Then this one's for the PLC. I also am going to make it float, and I put it here. You see? So there I'm going to edit faster. So here, what don't I have? Let me start from down. Reverse. When I come this way, let me extend this way extremely. Reverse. Here I'm going to there. Reverse is going to connect with the PLC reverse. Which is this one. So okay, I'm going to go to forward. The order does not matter, and I will not go speedy, just want to go slowly. It's going to connect with the PLC forward. Then a reverse memory 2, RX mem 2 is going to connect with the RX mem 2. What else? Forward sensor. Oh, forward sensor, it is not to be connected to the HMI. Oh, yeah. You have sensor signals in the HMI part. Yeah, it is necessary. So you have here FS as forward sensor. It's going to connect here to forward sensor. Then next is BS, back sensor. So it's going to connect here to the PLC tag, also called the back sensor. What next? You have FX memory 2. FX memory 2 is going to connect here to FX memory 2. What next is start memory. Do I have it there? But it's, yeah, start memory. I have a lamp there that is supposed to connect to start memory in the HMI. It's going to connect the PLC start memory. Then I have start memory, stop and start push buttons. Yeah, and the HMIs, they are there. Here do I have? So I have here start. It's going to connect to start. So okay. Then I have here stop. Is going to connect here to stop. So okay. What else? RX memory, I already have. RX button, ESFX memory. I think the rest I have, because here I have here 21 minus 3. Here I have how many tags? They must correspond the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Are I 17? Yeah, 20 minus D3, that is 17. Okay, let's first try these ones and see. So now when you come here to Here I'm going to come to attach. Also this one, going to come to attach it back. So I'm just going to come here to screens. Oh, now we have to edit animations for all these ones. Now what I'm going to do, since this one is the same lamp, I'm going to copy this one, and I'm just going to be changing the bits. Here is paste. It is here. So I'm going to delete this one and put. That one means even the animation styles, everything I've copied, even the bits, I'm just going to be changing the address, the tags. This one is already there. Again, I make another paste. I'm going to remove this one and put the one which has already properties. I just don't want to edit properties again. Then I have paste. Since they are going to all follow the same properties, I put here. Even this I can do the same. Here, this one I can do the same. But if you have time, maybe you want these lamps to be giving this different lights, you give them different properties and change different colors. So now here, this one forward, and you come here to properties. Remember this one we said we have animations, appearance. You see we already have it, is there. So only what you have to change is this tag. I'm going to give it forward output. This one, give it forward. Say okay. Only that one. Then this one, come and give it reverse. Say okay. Then this one, come and give it start memory, because the one that you have start memory. Also this one, give it start memory. Now since this one has to work and vice versa, I'm going to have here start memory. Where is it? Now here we are going to do, here is 1 and here is 0. Here is 0, the vice versa. I see, but the same address. Here is forward sensor. FS towards somewhere. Okay, this one is the reverse sensor, RS. I mean the BS. Back sensor. What is remaining? The upper ones are defined. So forward button, this one, we have events. Oh, you also have to set event. That one we are going to set, no problem. Forward button, come here, set bit, which bit tag, come here, FX button, say okay. Oh, outside click. No. I'm going to go back. So here when you press, I have here set bit. When you release, reset bit. Did I already figure this one? Let me see this one. RX. So I already set this one, so how come? Let me see this one. Okay. This one press. Here is set bit of which tag. If I have forgotten, we are going to reset them. I don't know how. Maybe I've forgotten. This one is the start button. Start. So okay. Then when you release, reset bit. There is a reset bit, which tag, the very start. Say okay. Then we have this one is press. I have tag here. Here is set bit. Which one is stop? Okay. When you release, we have which one? Here is the reset bit. Reset bit. Which one? Stop. So okay. Is there anything remaining? Let me see if I click here. This one is tag input reset, tag input reverse, tag input forward. Anything remaining? I don't see. So now, since we have these sensors here and the outputs, these ones are going to limit us from simulation unless we connect them. So let me first put this in simulation and see what happens. Where is the screen? And see if it is okay. Start. Start simulation with the screen conveyor control. Okay. It is already, here it is already in stop, but this stop has to work when it is in automatic, no error. So let's see forward, you release, let's see reverse, okay. So here let's go to manual, to automatic. Why is this lamp not lighting? Automatic is not switching, why? Have I made an error? Let me analyze it here in the main OB. Now there I also have a need of going to monitor mode. So here in monitor mode, I'm trying to switch automatic and reverse. Where are they? So it is in a manual, and here I have automatic button, auto memory. When I come here to the tags of the HMI, auto memory, where my screen. So here when I click automatic, auto memory is not self-folding. This one, auto memory is not self-folding. Why? But is it switching? Just want to see here if auto memory is switching. Oh, here I have manual button. Why is this one not going through? Oh, this one is still there. Why does manual button insist there? It's supposed to go on and off, on and off. So when I come this way, switch auto. Yes, something like that. So, but start. Already in start. Stop. Start. Stop. but when here I come to forward under auto, so it is okay. Just need to connect the what? The factory IO. So let me see. When in a manual, I can drive forward or reverse. But start and stop can't work. Start can't work. Then when I come to automatic, also forward here manual cannot work. But when I click here start, it can go, and stop can work. So the sensors and the working here, we need the conveyor. That is, we need the, okay. So this one is already there. Let's first come to manual. Don't close the simulation. Just leave simulations on. Then come to factory IO and start our file, and we see. So this is what we planned with the earlier in factory IO. So I'm going to eliminate this one. So we are going to come to file, drivers. So select here S7 PLC simulator. You can come here to configuration, add the number of counts here. You can make them 5. You also make them 5. You give the ones that you have. Me, I'm just putting S7-1200. Then say go back. You see when you increase here, it also increases. FS sensor, why is it already on? So now we have to connect. Remember FS sensor, we started from, let me check my ladder. Where was the sensors? Because I have only 2 input sensors and 2 outputs, reverse and forward. So forward sensor is 03, back sensor is 02. Okay. Back sensor is at 02. You see they are normally closed, they are red lighting. And forward sensor is 03. Now when you check that one in ladder logic, you see here it is not yet connected. Maybe, yeah, not yet connected. If I say here connect, then you come and check. You see this green line means it is closed. That's what I told you. Here it has to be normally closed, but since our sensor is normally closed, also it is going to help us close. So in the program you put normally open. The same happens to here. Where? The same happens to here. This one, no, not that one, the downer one. The downer one, which is this one. So now I'm going to connect the outputs, forward FX and RX reverse. Forward is M, was Y what? Do I still remember? Q01 and Q02. Okay. So forward is Q01 and reverse is Q02. If it fails, then it says start. Now I'm going to have my simulator here. I'm going to try to minimize the thing so that we can view. We start as we view. But the thing, I use the big screen, 7-inch of the HMI. But still we can go. So you see the sensors are already normally closed. They are showing. When you bring an object in the sensor, let me try, you see it is closed. Oh, it has gone off. Let me restart my object to come back. Just say here restart. So now when you're in manual and you say forward, you see, reverse. So when you come reverse up to the sensor, you see this one behind the sensor has gone. When you go forward, up to you block the sensor, it has blocked. Reverse, And when you go in automatic, then this one, forward and reverse, cannot work. So there, when you click start, reverse and forward, they are on at the same time. Stop. Why? What is happening here? Q1 and Q2 here, RX memory, RX memory 2, FX memory, FX memory 2. When I click, what happens in the ladder logic? Let me see. Start. RX memory 2, 14, M1.4. Why is it on with the same as M1.3? Why? Okay. Where is FX memory 2 and FX memory 2 and RX memory 2? We are going to come up and watch. There is a start. Now FX memory 2 is on, that is forward, and RX memory 2 is on. Why? Because this one and this one, they are the same. Here, instead of using RX memory here, again I used FX memory. So I'm self-holding it with again this one. You see? Okay, so what I'm going to do is go offline. Say yes. Then after going offline, now here, this is how we troubleshoot circuits. You can do this even when the machine is run mode. Come here and select RX instead of FX. That's why I don't like jumping anything, so that you can follow properly. From there, you have to compile afresh. Then from there, you do download to device. Then there you say load. It is finished. So me, even though I don't go into monitor mode, I just now want to verify this thing of mine with the factory IO now. So I'm going to click here, stop. Let me see, manual, automatic. So start, you see? So here what changes is the sensor status, and here forward reverse symbols. Are you seeing? Now it is in reverse. So hope you are seeing what is happening. So this is a tutorial of HMI beginner with the Siemens and the factory IO. So I think that there we are good to go. If you have not understood, it has been quite a long video, but you have to endure. Don't jump anything if you are to come up with the same concept. So remember, the idea is this design you can do your own. The ladder circuit you can do your way. Only what you are aiming at is this functionality, reverse, forward, the monitoring sensor status, and so when you click stop, it stops. Start, stop, and when in a manual, remember start and stop. There, it don't work. Only this is manual, you have to go forward and come reverse. So thanks for watching. See you when you see me.